Welcome to another tutor short provided by the Educational Support Services Department of Lehigh Carbon Community College in Schnecksville, Pennsylvania, which is just outside of Allentown. These videos review key learnings for the science courses provided here at L-Tri-C. And please remember that the Educational Support Services Department does provide walk-in tutoring 5 days a week. In this video, we will discuss two families of organic chemicals, the alkenes and the alkynes. There's already a video on the family of alkanes, and you should have reviewed that one before you move on to this video talking about alkenes and alkynes. And basically, alkenes and alkynes is just a build on the alkane family. In the alkane family, all your carbon-carbon bonds are single bonds, and when you move to alkenes, the only difference from alkanes is that somewhere in the molecule you'll have a carbon-carbon double bond. So you'll have that double bond, and because of that extra bond, you're going to see that your overall molecule is going to result in two less hydrogens than its corresponding alkane. And that's true, again, only if there's one double bond. And in most introductory organic chem or chem courses, you won't go really beyond one double bond. So that's all we're going to talk about today. And in the same way with alkynes, instead of somewhere having a double bond, you're going to have a triple bond between two carbons somewhere. Again, just one of them, and that will result in four less hydrogens from the corresponding alkane. Now, as similar to cycloalkanes, we also can have cycloalkenes, and that's just where, if I take the six-sided one, somewhere you have a double bond, and again, generally you're only going to deal with one, or you could have butane but throw in one double bond to be butene. And once you do this cyclic structure, remember that that also reduces another two hydrogens from your molecule, because your two N carbons come together to make the cyclic structure, and so you have dropped two more hydrogens. We do not talk about cycloalkynes where you have a triple bond somewhere, because they are generally very unstable and don't exist in nature until you get up into the C8s and C9 carbons, and so that's beyond what you'll learn in your introductory organic or chemistry courses. So when we go to naming, if you look back at my video on alkanes, there's I believe 5-step rules on how to go about naming alkanes. And really, if you are familiar with that, then this ruling here sort of builds on that ruling, looks very similar. A couple of differences, though, when you're naming either alkenes or alkynes. When you look for your longest continuous carbon chain, now you're going to look for the longest chain that includes the double bond or the triple bond. So that long chain needs to have that double or triple bond in it. So that'll make a little bit of difference when you're selecting your longest continuous chain, or that parent chain. Also, because it's in a different family, if that long chain has a double bond in it, you're going to end your parent with an ENE, and if it's a triple bond in that long chain, you're going to end in YNE. So before, so let's use examples: butane for your alkane. If there's a double bond in it, you're just going to do butene, end in ENE. And if it's a triple bond, you would use YNE as your ending. So that's what Rule 2 introduces. Rule number 3, another little variation in the ruling, is when you number your carbons from the parent chain, you're now going to base that numbering based on the double or triple bond. And you're going to make the double or triple bond have the lowest number when you go through the numbering. So if I say have this is a hexane sort of base, 6-carbon base, only we have a double bond, so we have hexene. We have a double bond, but we need to number the carbons so that we can show where the double bond occurs. And here you're going to go from the right to the left because you hit the double bond on the second carbon going from the right. If you come from the left, you don't hit the double bond till you hit carbon 4. And so you're going to go with the one with the lowest number. And when you actually number where that double bond is, you take the lowest number. This double bond is between 2 and 3 carbon. So you're going to call this a 2-hexene because you hit the double bond first at the second carbon. So this would be a 2-hexene from that point of view. And then the last rule here again is substituents. You may have something coming off the molecule like a methyl group, and substituents are treated the same way as they are when you're doing your alkanes. So now let's use an example I can walk you through so we can see how we would go about naming this compound, which is essentially the one I just drew for you. So we look at this. Rule number 1, if you remember, says look for your longest chain that includes the double bond. And there's 2 ways. I can go straight, take the straight chain here, and I have 1, 2, 3, 4, 5 carbons if I go that way. And the only other way I can do it is start up here and go this way to get a long chain. And again, that's still 5 carbons. And you should be aware by now, if both of them have the same number of carbons, it doesn't matter which way I pick, I'm going to end up with the same name. So we'll just go with the straight. So we know we have 5 carbons, so we know it's going to be a pent is the root of this name. It's a double bond, so we're going to add ene to the end, so we have a pentene. Now for that gets rule 1 and 2. And now if we go to rule number 3, numbering the carbons, we go this way, the double bond starts at carbon 2. If we go this way, it's carbon 4. Therefore, we're going to go with right to left. And the first carbon that you hit with the double bond is number 2. So it's a 2-pentene. And all that's remaining here is there is one other thing on this molecule. There's a methyl group. And so we need to identify that in the name. Again, the numbering has been done by the double bond. So this carbon now is carbon 4. So the methyl group is on carbon 4. So we have a 4-methyl 2-pentene. Is how you would name this molecule. On this slide, I'm going to bring up another nuance that is involved with alkenes when you do naming. And I'll introduce this by starting up here. When you have butane, typically can be shown in this molecular formula, and that's a normal alkane, the butane formula. Now, if I add a double bond over here, and I show the formula like this, you can see that in the middle here I have where I have CH and CH. That's where my double bond resides. And so if I just name that molecular formula, I have a 2-butene. I got 4 carbons, the double bond's in the middle, and therefore it's a 2-butene. However, if I'm given a different structure for that molecule in a test or say in a book where it's expanded, where they draw out the carbons and the hydrogens. So again, I have a bute base, a 4-carbon base, double bonds in the middle, when I fill in my hydrogens, I got my hydrogens on the end, the 3. But on the middle carbons here, where I have the double bond, I can draw my hydrogens across from each other, or I can draw them on the same side, either on top or down the bottom. For a double bond, it makes a big difference whether I draw them across from each other or on the same side. And the reason for that, again, if you look down here at butane, when we have single bonds in the carbon, because of this single bonds, let's look at this one here. This is the one that's going to be a double bond as we go to butene. Because it's a single bond, these carbons are free to rotate around. If you think about holding this molecule in your hand, this actual, call it a toy if you want, but if you can hold these pieces of plastic in your hand, you can spin these molecules very easily, or the atoms. You can spin the ones on the ends, and you can spin the 2 in the middle. So they can spin around, and the hydrogens, which are the white dots here, can spin around and be in different places as you spin it. But as soon as you put a double bond in, and let's look here, we've added a double bond between the 2 metal carbons. Now if you held this model in your hand and you tried to spin these 2 carbons in the middle in any direction, they're not going to spin. The double bond is rigid and doesn't allow these hydrogens here to spin around with respect to each other. They'll always be on the opposite side of each other. These hydrogens, again, on the end, they can spin because they're only this carbon's only attached with a single bond. But the 2 in the middle, those hydrogens are now stuck across from each other. And if you look at this one here, if I put the model this way, the hydrogens are stuck on the same side of the carbons, or on the same side of the molecule. And so once I draw an expanded structure of the molecule, I now have a sort of a decision to make of which way do I draw it. So when the hydrogens here in this one, hydrogens are across from each other, that is called a trans isomer. So it's a trans to butene. Remember, I should have mentioned a little bit earlier, isomers. Same molecular formula for the molecules, but different structure. And so this is a trans form of 2-butene. Trans meaning across, or you can think of transportation, or maybe some students will use trains. They're across from each other, apart. And if they're on this side here, where they're next to each other, that is called a cis 2-butene. And what I like to use to remember that, when I think of cis, I think of sister. And to me, sisters should be together or on the same side. And so the hydrogens here are on the same side of the molecule. They're next to each other. So it's a cis isomer of 2-butene. So this is another nuance that you'll come across in your studies, that if you draw an expanded structure, now you have to identify whether with a double bond you have a cis or trans isomer. That does not occur with a alkyne, a triple bond, so it's only related to alkenes. Finally, we're going to look at naming cycloalkenes, because they also have a nuance compared to cycloalkanes. Here on the left, I show 3 sort of unique things you have to remember with cycloalkenes. Your double bond takes precedent over substituents when you number your carbons, and you must cross the double bond first when numbering your carbons and need to add cyclo to the parent name. So let's look at this example we have here. Our cyclic compound has 5 carbons, so the root of that is pent, and because there's a double bond, it's a pentene, and because it's cyclic, rule number 3 here, you're going to have cyclo. So the base is a base name here is cyclopentene. But now we also have to worry about the methyl group up here, a substituent. And we have to identify that there is a substituent methyl group on this cyclopentene. So the rule sort of start with number one. We need to name or number the carbons in this structure. And what's going to take precedent is a double bond. So that means that this carbon has to be number one or that carbon has to be number one. We have a choice between those two carbons in setting them as number one because there's two carbons associated with the double bond. Now, we know we have to start with one of those two carbons, but rule number two here says that once we pick one as a one, then we have to cross the double bond as we number. So if we start here, if we say that's number one carbon, number two has to be across the double bond. So that has to be 2. And so now we're going in a counterclockwise rotation. This is 3, this is 4, and this is 5. So if we pick it that way, the methyl group here would be a 3-methyl group. If we reverse the role though, if we make this number 1, then your carbon numbering is going to cross the double bond first. This is 2, 3, 4, and 5. Now the methyl group is on 5. So it's a 5-methyl. And as you would expect, you always number so that you get the smallest overall numbering. And so in this case, we're going to number it and select number 1 carbon to get a 3-methyl group. So our answer essentially for the name of this compound, if I can fit it in here, is a 3-methyl cyclopentene. So again, remember as you're doing cycloalkenes that there is this nuance to deal with the double bond. And finally, just to remind you again, triple bond cyclic compounds are very unstable until you get up to 8 carbons and higher. So generally you will not come across them in your introductory chemistry courses. Thank you.